Dear colleagues, ladies and gentlemen, first of all, presentation of this talk together with Seppo Knuuttila, Jouni Lehtoranta, and Mika Raateoja, who is now in Helsinki, probably watching this. We are very thankful for having this opportunity to have this keynote talk. We appreciate this very much. Our topic is comprehensive monitoring of nutrient concentrations and loads and its importance from judging the changes in the state of the Gulf of Finland and in these evaluations. This topic is by no means a new one. Before coming here, I look at my archives and found that we have had similar topics in the scientific meetings concerning the Gulf of Finland and the Baltic Sea already in the 1980s. And for example, my first presentation has been in 1986 in the joint Gulf of Finland meeting here in Tallinn. So, going to the presentation. Do I have to next? Okay, this is shortly the contents. First, something about the main processes affecting the trophic status of the Gulf of Finland. So, what is the role of internal processes? How do they affect the trophic status and nutrient dynamics? And on the other hand, what's the role of the land-based loading? Then we will have some examples on long-term nutrient trends. Not very many, but some, let's say, examples using representative data from the middle and eastern Gulf of Finland. And also looking at the long-term variations. For example, the question is eutrophication of the Gulf of Finland still continuing? Then one really important question is the quality assurance. During the Gulf of Finland year, we noticed that even the data of nutrients, it's not fully comparable between the different countries. And finally, we have some proposal for the future Gulf of Finland Trilateral cooperation. So first about the role of internal processes, nutrient transport between the basins, and especially the role
Recording stopped.
Thank you. The role of the Baltic proper, which has proved to be really important, also controlling and regulating the state of the Gulf of Finland. Here is, okay, I can show here. This is there is a schematic presentation from the paper of Lehtoranta and the others, how during eastern, northeastern, and also weak westerly winds, the role of the large nutrient storage in the Baltic proper can be and is really important, also controlling the status of the Gulf of Finland. And also, it's really important to notice that when external nutrient load from the drainage basin of the Gulf of Finland has strongly decreased in recent decades, on the other hand, the role of the Baltic proper and the anoxic water volume has increased very strongly, and its role has become more and more important all the time. So even the present annual load of land-based phosphorus is somewhere between 3,000 and 4,000 tons. It's as such it's a big amount. It's important to notice that it's only 10% of the wintertime total phosphorus content of the Gulf of Finland. So it's possible when further decreasing this load, it's self-evident that decreasing the load affects the state of the Gulf very, very slowly. Here are some examples about very strong nutrient load reductions from the main point sources around the Gulf of Finland. So these are cities. Of course, the most important is the load from St. Petersburg, which has decreased really strongly from the 1980s. Both phosphorus, this light gray, and also nitrogen. Light gray is nitrogen, and dark gray is phosphorus. But similar, in a smaller scale, similar development also in the Helsinki-Espoo region and in Tallinn. Then we had this a bit surprising episode via the river Luga, where we had very high phosphorus inputs from this phosphorus gypsum stack in the town of Kingisepp, which affected the loads of river Luga, and in a way for some years counteracted the decreasing load from the other sources. Then some examples about the trends. We have here the from the LL7 station, which is between Helsinki and Tallinn. We made some handled some extra data after the Gulf of Finland year. So these orange dots are after 2015, and notice that there are certain changes. The long-term trend regarding both phosphate and nitrates, the long-term trend is increasing, but for example, regarding phosphate, there is a change. That we had a slight decreasing trend in the 2000s before 2016, but then the situation changed because we had these major Baltic inflows in 2014, between 2014 and 2016, which again increased the concentrations here. Regarding nitrate, the trend is not as clear as for phosphate. Very strong increase in the 1970s, 1980s, along with the general eutrophication development in the Baltic Sea. But then, if you look at the salinity trend, there is an average decrease from the 1970s, which means that the role of river water has increased all the time. And it affects especially these certain higher concentrations. The general trend is quite there is no trend in the 2000s, but in a way the variation has increased. And talking about the reliability of the data, we really checked the Finnish data. We noticed that the Finnish data between 2000 and 2014 is not okay, and made a study and noticed that concentrations below 0.7 micromoles or 22 micrograms per liter, they are not, or the uncertainty had increased, and we decided to delete these values. Let's say from normal use, you can't get them anymore automatically from our database. You can get them if you want, but then you had to make a special handling for the when you are picking up the data. These are figures from the Eastern Gulf, from Finland. This is the station south from Haapasaari. It more or less presents the open sea conditions, and here we can see the same effect. So this is now total phosphorus, summertime total phosphorus. This downward trend, which was noticed during the Gulf of Finland year 2014, ends here, and the New Year data is clearly higher, and our analysis is that, or we think that the main reason for this is these Baltic major inflows, or they are indirect effect which pushed this old deep water into the Gulf of Finland. And also we can see here that near bottom salinities, especially in 2018, 2019, they are clearly higher than the average level. Now, here are something about the challenges which make the judgments related to this basic monitoring data a bit challenging. So there is the basic thing is the estuarine-like. Oh, I have to show from here. Yeah, estuarine-like system. So we had a strong freshwater effect in the east, and then saline, nutrient-rich water input below the halocline from the west, and these different water masses are mixing and causing strong gradients. Monitoring aims to follow and analyze changes caused by anthropogenic loading to help to perform measures to reduce this loading and improve the state of the ecosystem. And these anthropogenic effects, of course, should be possible to separate from these, let's say, natural effects. Of course, these natural effects also nowadays contains anthropogenic nutrients as well. But this is very challenging because, especially in the open sea, the amounts of loading are much more than those caused by processes in the sea. So theoretically, if we, for example, cut 1,000 tons of phosphorus from the inputs from the drainage basin, on average, it means only 1 microgram or 3 micromole of phosphorus in the let's say compared with the whole water volume of the Gulf of Finland. So it's easy to understand that seeing the effects on the state of the Gulf takes really a long time. Then some words about the importance of quality assurance. I already mentioned the problem we had in Finland. During the Gulf of Finland year, this kind of comparison between Estonian and Finnish concentrations from the stations near to each other were made, and theoretically, of course, they were not made from just the same samples, but this the value should be quite near this 1-to-1 level. But as you can see, the deviation is quite big. Of course, the different sampling times, for example, explain part of this. Then Mika Raateoja arranged an intercalibration experiment in 2019, and those results were quite good. So the differences were mostly acceptable. Then I also mentioned the problem with the river monitoring. So this is from Neva. We have here flow and here phosphorus flow, and practically no correlation between these two others. There should be, because flow, this export is also including flow. So there should be a positive trend between these two. And finally, some proposals regarding the future Gulf of Finland cooperation. The present situation is that monitoring based on research vessels still forms the basis for this monitoring. It's important to have good coordination between the 3 countries, and really this nutrient data very much forms the basis, and especially the winter data forms the basis for analysis about the trends and explains the changes in eutrophication. Of course, measurements should be developed, and there is going on development with the moored automatic stations, ferry box work, etc. And from these measurements we will get the needed high-frequency temporal coverage data. Regular intercalibrations are needed between the countries, as was done in 2019. So it should be a continuous process. And we also feel that data exchange and annual reporting, as was done in connection with the Gulf of Finland 2000 year, should be a regular BNL process to follow the data quality and changes in the state of the Gulf of Finland. This applies both monitoring nutrients in both seawater and land-based sources. Thank you very much.
Thank you very much, Heikki, for making clear that it takes time for the sea to become cleaner, and that there is enormous uncertainties in what we are doing. Any questions, please? Yes, Kai. Please use the microphone so everybody will hear.
Thank you. Thank you, Heikki, very much. I think that we this message which you thought about the role of internal loading and this major Baltic inflows in comparison with the reduction of the external loading is sometimes not reached by our society, because often you hear just that we should decrease the external loading, but now you show that it's not maybe the very quick solution. So what do you think that we should do to give to the stakeholders and decision makers a more updated view of the situation? Thanks.
Yeah, I believe that, or also my colleagues agree that we should still reduce the external loading as much as possible, because slowly it will affect. But in shorter time scales, it's this nutrient exchange with the Baltic proper and internal processes which really affect. We have good signs in the eastern Gulf of Finland. There are clear trends in the Russian side of the Gulf of Finland where the main load decreases have taken place. There we have decreasing trends which are mostly caused by this decreased loading. And it affects also elsewhere, but it's masked by these processes.
Yes, the theoretician may say that let's dry the Baltic Sea, clean bottom sediments, and put new water in. Okay. You don't agree? Me too. Thank you very much, Heikki.
Thank you.